What if the blueprint for your smartphone was written 2,000 years ago? And what if the secret to self-healing buildings wasn't some modern breakthrough, but a forgotten Roman recipe? Sounds like science fiction, right? But history is littered with inventions so advanced and minds so brilliant, they completely defy our understanding of the past. These weren't just thinkers, they were architects of the future, living in a world that just wasn't ready for them. We tend to picture the ancient world in pretty simple terms: chariots, swords, and stone tablets. But hiding in the ruins of fallen empires and tucked away in dusty old manuscripts are technologies that rival the complexity of our own time. These are the masterworks of geniuses who didn't just push the boundaries of their world, they completely shattered them. Today, we're counting down the most incredible examples of ancient minds who invented the future, hundreds or even thousands of years ahead of schedule. From analog computers built by Greeks to earthquake detectors from ancient China, get ready to have your idea of history completely rewritten. Back in 1901, a group of sponge divers off the coast of the Greek island of Antikythera found something that would baffle scientists for over a century. Lying in the wreckage of a Roman-era cargo ship was a lump of corroded bronze, no bigger than a shoebox. For decades, it was just another artifact. But as our own technology got better, allowing us to peek inside, we realized it was something truly extraordinary. This was the Antikythera mechanism, an astronomical calculator of breathtaking complexity. Dating back over 2,000 years, this device is now considered the world's first analog computer. It was a clockwork universe made of at least 30 intricate bronze gears, and it could predict the positions of the sun, moon, and the 5 planets you can see with the naked eye. It could forecast lunar and solar eclipses with incredible accuracy and even track the 4-year cycle of the ancient Olympic Games. The level of engineering and astronomical knowledge needed to build it was thought to be impossible at that time. Nothing even close to its sophistication shows up again for over 1,000 years, until the astronomical clocks of medieval Europe. Modern research is still unlocking its secrets. Using advanced 3D modeling and statistical analysis, scientists have even debated whether its calendar ring tracked a 354-day lunar year or a 365-day solar year. And while some recent simulations suggest that manufacturing flaws could have caused the gears to jam, the sheer concept of it remains a marvel. The Antikythera mechanism makes you wonder, what other technological wonders from the ancient world are still lost to the depths of time? The Roman Empire is famous for its roads, aqueducts, and massive buildings, but the real genius behind their staying power is a material they perfected: Roman concrete. We think of concrete as a modern thing, but the Romans came up with a unique formula that let their creations, like the Pantheon and the Colosseum, stand for almost 2,000 years. In fact, the Pantheon still holds the record for the world's largest unreinforced concrete dome, an engineering feat that continues to blow architects' minds today. For years, the secret to its incredible durability was a total mystery. Modern concrete, in comparison, can fall apart in just a few decades, especially when it's out in the elements. But recent discoveries have finally revealed the Romans' trick. The key ingredient was volcanic ash, which they mixed with lime and seawater. But it's how they mixed it that made all the difference. Researchers from places like MIT and Harvard discovered that the Romans likely used a hot mixing process with quicklime. This created tiny, brittle chunks of lime inside the concrete. These weren't a mistake or a sign of sloppy work, as people used to think. They were an ingenious self-healing mechanism. When tiny cracks start to form into concrete, they run into these lime clasts. Water seeps in and reacts with the lime, creating a calcium-rich solution that recrystallizes, filling the crack and stopping the damage from spreading. In structures by the sea, this process is even more effective, as seawater reacted with the volcanic ash to form rare minerals that actually made the concrete stronger over time. This ancient recipe, which uses natural chemistry to create a living, healing structure, is now inspiring scientists to develop better, more sustainable building materials for our own world. In the year 132 AD, almost 2,000 years before modern seismology, a Chinese genius named Zhang Heng showed off an invention to the Han imperial court that seemed like pure magic. It was a huge, ornate bronze jar, about 6 feet across, decorated with 8 dragon heads, each one facing a different compass direction. Below each dragon sat a little bronze toad with its mouth open wide. This was the Hufeng Didong Yi, the world's very first earthquake detector. Zhang claimed his device could detect earthquakes from hundreds of miles away, and even more impressively, tell you which direction they came from. The court was, to put it mildly, skeptical. But one day, a dragon dropped its bronze ball into the mouth of the toad that faced west. Nobody in the capital had felt a single tremor. Zhang's rivals at court probably had a good laugh, but a few days later, a messenger showed up with the news of a huge earthquake that had struck a province hundreds of miles to the west, exactly where the device had pointed. The exact inner workings of Zhang Heng's seismoscope are still a mystery, since the original was lost to history. Historians believe it had a sophisticated pendulum or a similar system inside. When the first tremor from a distant earthquake reached the device, the internal mechanism would shift, triggering a lever that released the bronze ball from the right dragon's mouth. It was a revolutionary idea. What's truly astounding is that the modern attempts to replicate the seismoscope have struggled to achieve the same sensitivity described in historical records, proving that Zhang Heng was a true master of his craft. Legends from the Crusades told of swords so sharp they could slice through a piece of silk floating in the air, but so strong they could cut through an enemy's armor without getting dull. These were blades made from Damascus steel, a material famous for its incredible strength, flexibility, and its unique, watery-looking pattern. This metal first appeared around 3000 BCE and was made from a specific high-carbon steel from India called Wootz steel. Blacksmiths in the Near East, especially in the city of Damascus, became masters at forging it. The exact method was a closely guarded secret, passed down through generations. But it involved a complex process of heating, hammering, and folding over and over. This technique created a unique internal structure, with alternating layers of hard, brittle material and softer, more flexible layers, which gave the blades their legendary qualities. For centuries, people have tried to replicate true Damascus steel, but the original recipe was lost sometime around the 18th century. Modern science, using powerful microscopes, has revealed that the secret might be in carbon nanotubes and specific trace elements like vanadium that were in the original Indian ore. While modern, pattern-wielded steel can copy the look of Damascus steel, recreating the exact properties of those original Wootz-forged blades is still a holy grail for metallurgists. The mystery of Damascus steel is a powerful reminder that sometimes ancient artisans knew things about materials that we're only just starting to figure out. Some geniuses can't be defined by just one invention, but by a flood of ideas that were centuries ahead of their time. Two of the greatest examples have to be Archimedes of Syracuse and Leonardo da Vinci. Archimedes, living in ancient Greece over 2,200 years ago, laid the groundwork for huge parts of math and physics. He calculated a shockingly accurate value for pi, developed the principles of buoyancy while, as legend has it, shouting "Eureka!" and he established the laws of the lever and the pulley. But his genius wasn't just on paper. He invented the Archimedes screw, a device for raising water that's still used for irrigation today. And during the Roman siege of his home city, Syracuse, he designed incredible war machines, including massive claws that could supposedly lift enemy ships right out of the water, and possibly even a heat ray that used mirrors to set them on fire. Then, over 1,500 years later, Leonardo da Vinci showed up during the Italian Renaissance as the ultimate polymath. We celebrate him for his art, but his private notebooks were filled with inventions that wouldn't become real for centuries. He sketched detailed designs for flying machines like helicopters and gliders, an armored car that was basically a blueprint for the modern tank, and even a scuba diving suit. His anatomical studies were so precise they helped form the basis of modern medicine, and his engineering ideas for bridges and hydraulic systems were game changers. Just like Archimedes, Leonardo blended art and science, theory and practice, to imagine a future that was way beyond the horizon of his own world. From self-healing concrete to ancient computers and earthquake detectors, these inventions are way more than just historical oddities. They're proof of the incredible, boundless potential of human ingenuity. The geniuses behind them, Archimedes, Zhang Heng, Leonardo da Vinci, and all those unknown engineers from Greece and Rome, weren't held back by the limits of their time. They saw the world not just for what it was, but for what it could be. Their stories are a good check on our modern ego, reminding us that wisdom and innovation aren't just a product of our time. The past is still full of mysteries waiting to be uncovered and lessons we've yet to learn. You have to wonder, what other forgotten technologies are still out there, just